Hi everyone, I'm Kunal. My background is in computer science and AI systems, and I'm particularly interested in how we can move from AI tools to autonomous goal-driven systems. In this project, I focus on the core system architecture and the technical formulation, including the math rigor and R&D. Specifically, how outbound can be modeled as an autonomous decision-making problem rather than a workflow. Okay. Coming to the introduction of our problem statement and then the current, what do you say, drawbacks. Today, outbound is everywhere. Hiring, sales, partnerships, but it's fundamentally optimized for the wrong thing. Most outbound tools optimize for how many messages are sent, and then what are the open rates, and then the reply percentages, all these KPIs. But businesses don't care about messages. They care about the outcomes from a particular campaign or a particular outreach. So we ask the simple but radical question. What if outbound were judged by outcomes instead of messages? And built as an autonomous system instead of a workflow consisting of too many employees. So that is the motivation behind OutcomeFlow AI. uh, we define the outcomes instead of following a predefined workflow. Even with AI today, outbound is still manual. Humans decide who to contact, humans design sequences, and then humans monitor dashboards, humans decide when to stop. AI is mostly used for copy generation and not decision making. From a systems perspective, this is inefficient because outbound is inherently a sequential decision process with delayed rewards and constraints. But we treat it like a static pipeline. So our core idea revolves around this. This is the mathematical formulation as in how our system is going to work. I'll come to explaining this later. We have a desired outcome defined, and then we have a prospective universe, which are our target audience set, and then we have different constraints, mostly operational constraints, but then we do also consider ethical boundaries too. And then human intervention is human on the loop to look over the process. So with minimal human intervention, we plan to what do you say, complete the workflow. This is the system architecture. Our core idea. Outcome flow AI flips this paradigm. I mean, you don't send messages, you define the outcomes. For example, let us say hire three ML engineers in 10 days is our prompt, and or book five qualified calls for this week. Once the outcome is defined, the system plans autonomously, executes the outreach, interprets the responses, learns and adapts, and stops automatically when the outcome is achieved. This is outbound as an autonomous goal-driven system. So, architecture overview. I'll now briefly walk you through the system architecture, focusing on the technical novelty. Okay. The system is defined as a closed loop control system, not as a campaign engine. So, coming to the key technical contribution is it is goal conditioned orchestration. The core innovation is what we call goal conditioned orchestration engine. A traditional outbound system, any traditional outbound system in any of the big companies which you look up, they rely on fixed sequences and then predefined funnels and rule-based branching. Maybe there is some dynamic branching, but then most of it is rule-based. Okay. So outcome flow AI does something fundamentally different. At every step, the system chooses an action according to what do you say, the mathematically defined function pi of A or STGC. Let me just show it. Yeah, this pi of STGC. Okay, this is the optimization objective. You can see the user defines the outcomes, and then the orchestrator plans the actions. The system learns from the feedback. The prospect intelligence analyzes the context. AI executes across the channels and stops when the goal is achieved. And how are we going to do it? That is the main question, mathematically. So I spent all these days driving, what do you say, strong theoretical and mathematical backing for the system which we've designed. The ST, which I've showed earlier in the previous slide, it defines the current system state. And then G is the target outcome embedding, and C is the ethical and operational constraints. So this means there are no static sequences and then the system replans continuously and adapts to new, what do you say, environment and the new, uh, what do you say, problems or situations. Okay, every actual, every action is evaluated based on progress towards the outcome. So the mathematical framing is a real flex moment because we formally model outbound as an constrained Markov decision process. Markov decision process comes from reinforcement learning. So the key aspects is the reward is sparse and outcome aligned, no reward for sending messages, and then reward only when the outcome is achieved, and constraints are enforced via rate limits, consent rules, fairness and safety checks. And then we optimize all of this using a Lagrangian formulation, which allows soft constraint and enforcement, ethical behavior inside the optimization loop, and automatic stopping when further actions are no longer beneficial. Additionally, we do also share the policy using semantic intent feedback, which in normal terms means that it's not just binary replies, but why someone has responded. So we'll be analyzing that too. We'll be analyzing the intent. Uh, we'll move on to the next slide. This is the prospect intelligence. So coming to our choice of LLMs. So for the orchestrator, this is a very important signal, the LLM design choice, a critical design decision because LLMs are not in the control loop. We use LLMs only for strategy reasoning, message generation, and response intent classification. Because if we use them in the loop, there is a high risk of hallucination and then, what do you say, a wastage of high power computation. So all orchestration constraints and topic logic are deterministic, they are rule constrained and low latency. We won't be depending upon LLMs. So there is no hallucination and then there is no wastage of compute power. This makes the system totally scalable and very much predictable and explainable. So this is not LLM as the brain, but it is LLM as a component of a bigger system. Coming to the ethics and safety of our system, this is the we'll shortly share this. Yeah, um, just a second. So why would this matter? The autonomy without control is dangerous. So ethical constraints are embedded directly into the decision process. Hard limits on outreach and then consent aware behavior, a mandatory human approval for high risk actions because let us say it is a very high net worth individual as your client. So you would need a mandatory human approval. You cannot blindly go on what do you say an LLM given decision. Like so the system is autonomous but never accountable because you will always have human over the loop. Most of it is automated, but then only such high impactful decisions are forwarded to human for a recheck. And why does this matter? Because it represents a new abstraction for outbound systems. OutcomeFlow AI is not just a better outbound copy. It is a shift from workflows to autonomous agents and then optimization of real world problems, not vanity metrics. All right. We expect three times faster outcomes and then 60% fewer messages because all of it is already in a predefined workflow and it is dynamically changing according to your situation. And then we have 0% constant violations because LLM is just a component and not the brain. So there is there is zero chance of hallucination. So yeah, uh, that is the end. And so what we would like to end on a note that outbound shouldn't be about sending messages, but rather it should be about achieving outcomes. And outcome flow AI makes that shift real. From here on, my friend Dimple, my teammate, she'd be explaining the complete overall architecture, the non-technical part. Without the technical novelty. But yeah, thank you.
Hello everyone, I'm Dimple Bongu, currently pursuing ECE at Amrita Vishwa Vidyapeetham. Thank you for this opportunity. Now let me briefly walk you through how the system works. First comes the output definition layer in which the user defines goals, success criteria, constraints, and the human approval rules. This converts the intent into machine readable objective. Next comes the prospect intelligence graphs. In this, instead of flat list, we build graph of prospects which defines people, companies, roles, and the activity signals. This helps the system reason whom should I contact and why. Next comes the goal condition orchestration engine. This is the key innovation and basically the heart of the system. In this, instead of static policy, we use goal condition policy. So at every step, the system asks which action moves me closer to the outcome under the constraint. Actions are decided automatically. Whom to contact, which channel, what intent framing, and when to act. So this makes the system adaptable and not scripted. Next is LLM's reasoning core, which is lightweight by design. We use LLMs where reasoning is required, for example, strategy generation and message synthesis. LLMs don't control orchestration, control logic is deterministic and fast. So, this keeps the system scalable, explainable, and has low latency. Lastly, response interpretation and learning loop. Each response is classified semantically positive, objection, delay, and a hard no. The feedback updates the policy in real time. The system learns which personas to respond, which strategies fail, and when to stop. This is the overall idea of the system. Thank you.